as a service. So I think I leave the floor to you. And you said that if you like to, you can ask questions during the presentation.
Yes, please feel free to interrupt us at any time to ask any questions. If we talk about something that you don't really understand, or if there's any details you want to know, just feel free to ask anytime. Yes, and my name is Patrik. I actually studied 5 years now for industrial engineering and management. We have a bit of different backgrounds, so the thesis we done together was also partly separated. We will explain why and how and what those different parts were as well. I'm currently working with IT now as an IT consultant, but yeah, I don't know. I'm 29 years old. Small details about me. I live in Gothenburg. Yeah, that's pretty much.
So we're gonna start with like a very brief introduction of how we came together to do this report, because I'm from the physics department and he's from the what's it called? Management and innovation. So obviously two very different parts of education. So yeah, kick it off with how we got together.
Yes, so at Chalmers there has been established a lab called the Challenge Lab, where students take on great challenges within society. And this was actually started more than a year ago, where we took a course, preparatory course called Sustainable.
I don't remember.
No, I don't know why I can't remember.
The main takeaway from Challenge Lab is that a lot of students from different master's program get together, and together we get to define what sustainability means and how we can relate to that. And from that perspective that we create together, we start looking at problems in society and how we can address them with our vastly different experiences in engineering.
Yeah. So if you're interested in the lab, just feel free to go online and you can find the information about the course there. Hopefully, I'm sorry I forgot the name of it. But also, when we met in the lab, we actually established some common interests as well, where I started to look at blockchain technology in 2011, but then it was like bitcoins and was quite hype about the technology back then, and I started to figure out the economics around it, but that was kind of in outside of academia. So yes.
Blockchain.
Yes.
I'm here to learn what it is.
Yeah. Exactly, I will tell you a bit.
What is the word? What does it mean?
It's like literally, it's like blockchain. It's like the meaning of the word quite good explains the whole concept.
Yeah, but we're gonna get to that later in the presentation. So
yeah. So within this lab, we started out the thesis work with some problems. So we had to define this kind of criteria for sustainability and a framework for that. And our approach in this year was to look at mobility, and mobility as in movement and how you transport yourself or goods and what that means. And we carved out the concept of mobility as a service in this process, which was 4 weeks long, and it started out we were 16 students, and we all had to define our own scope of what we wanted to do in the lab. And we didn't start out with a thesis proposal or some research question. That was made by us on the way.
Yeah, that's part of the process of doing our thesis.
Yeah. So in last year then was 3 themes. It was mobility, urban futures, and circular products and services. And we focused on this challenge because as you can see and you all agree, it's a big need of transformation. So also there's some background story to why we started out with mobility as a service, because in Gothenburg there has been previous efforts within both academia and in the Research Institute of Sweden, RISE, started out with some projects. And there's also an organization I will talk about later called Samtrafiken that has done some earlier works. And it was one project called Yubico, which was a subscription service where you could use like the public transport system, Västtrafik, together with some of the actors here, like Volvo. They have this service called Sunfleet, and which is a car sharing service. And you can also integrate like renting bikes and different modes of transports on this platform. But this is like Web 2.0 system as we describe it. And Web 2.0 is like you have some kind of platform, but this platform operates within the web as we know it, like the World Wide Web. And it uses like APIs to connect to different services, and you need to actively build those kind of interfaces and inter-exchanges between these services.
And I think another major point is that these platforms in the traditional web is owned by a specific entity, like a company or some other type of organization.
Yes. So all these stakeholders that are involved, they tend to create organizations like Samtrafiken or these kind of clusters of organizations to solve these issues that we have. And in Scandinavia, Finland has been quite innovative in this field as well. And we try to take the knowledge available to us now and try to innovate as well. And the result of this was our research question. That was, how can I combine mobility service platform that benefits all of the involved stakeholders be designed? So we try to find these kind of issues that the stakeholders have and identify them and try to figure out a viable solution. So
can we maybe unpack the word combined mobility service platform?
This was one of the first issues we stumbled upon in the work, that we try to define mobility as well as what is the combined mobility service. We had some intelligent transport systems. We have like ITS, CMS and MAAS and all these kind of acronyms that we had to deal with in the beginning. And actually I didn't write down what this kind of combined mobility service stems from, but that the focus we had here was on transports of people, not transport of goods, which was kind of our our limits within the scope of the project. And our aim was to look at Yubico as a starting point, and we used a different process. I will tell you about this as well. In the Challenge Lab, we have two phases of our thesis work. This is the first 4 weeks, and the phase 2 is the rest until end of May, when we finalize the report. So in the Challenge Lab, we are taught a framework called backcasting. How many of you have heard about backcasting before? Some of you, yeah. So as you saw in the first picture, John Holmberg, the professor and founder of the Challenge Lab, he has been involved in using the backcasting process in different areas, and he started out with using backcasting in environmental studies, right? And started the industrial ecology program at Chalmers. And what we try to do with this is to define the criteria for sustainability, which also includes the framework. And then we describe the present situation in relation to this framework. And then we envision the future solution. And that was like where we started out to figure out, like, can blockchain be a possible or viable solution? And then we define strategies towards sustainability. This is a very simplified model of backcasting, but you can see it as a tool, like a strategy tool, that instead of using scenarios or yeah, it's like a strategy tool. I won't go into details of the other ones, but yeah. So these first weeks also includes stakeholder dialogues, which is separated from the research here, where we have interviews. And in the stakeholder dialogues, we have a process we call fish bowls, which is we sit down in two separate rings of people, where the inner ring is consisting with the stakeholders, and then we have two students that facilitates the discussion within that ring, and then we have an outer ring with people that are listening, and then it's like 3 different episodes in this discussion, where the first is the stakeholders. They are trying to surface the problems they have, like, and the students' role there is to facilitate and like lit the fire, and then the discussion starts. Like, they start to argue about why do we have this situation in our in the mobility. Like, we have different stakeholders for mobility. They started to discuss, like, why can't we communicate like this, and why is the situation like that, and then they can all agree, like, on this common criteria, that pollution is bad, congestion is bad, and then we start to, like, figure out what the viable possible solution is. And the next step is the outer ring, us and our friends, that we can start to ask questions and interfere in the inner ring's discussions. And then in the third section, the discussion goes into the inner ring again, and they can start to answer those questions. And that's the thing of the fishbowl, that you can have this kind of iterative process where you can communicate in a certain way. And yeah, the mainly because of we focused on blockchain technology, the main sources of information in this study was dates back from 2014 and onward. We didn't use any sources earlier than that, and there was also a problem to find sources including blockchain and mobility as to search keywords, because of natural causes, that blockchain is such a new concept. Now I'm starting to move into phase 2. Actually, I started to talk about literature review, if that was not obvious. And yeah.
How did you consolidate what your future solution was? Because I can imagine there was a lot of debate going on, and how did you get back to?
So I think one of the things that we didn't mention is that we were 16 students who defined the common framework for what the sustainable future would be, and then we kind of started looking at what kind of things can we actually do something with, and what kind of solutions can we come up with. And in the end, we ended up with pairs of 2 students who addressed one problem. So that, I think that kind of answers your question, since we split up and took parts of the whole.
Yeah. And now when I start to think about it, like how we ended up together was that during this first 4 weeks, Joel were actually wearing a T-shirt with a logo on it, and I asked you, like, is that the Ethereum logo? And you was like, yes. Oh, I know about that. I read about that somewhere. And then we started to talk about blockchain, and also there has been some other projects that are actually tried to build a platform for mobility, but that was focused on some other types of problems that we did, and also that was kind of the starting point, how we two ended up together. I don't know if that was some part of the answer.
I guess the third step is the hardest.
About the interviews, this kind of design, it's very abstract, but we try to include in the literature review and in the interview section and the simulation, we included these concepts of ecosystems and platforms, and some parts of them stems from my domain, and some part of them stems from complex adaptive systems. So it's a combination there. Blockchain, a completely new domain in academia. Agent-based modeling. This is where it differs. Like, I never heard about agent-based modeling before I met Joel. So because of his master program, he had to include that in his thesis. So I can't really take credit
also
for that.
Also because it's fun.
Oh, yeah. So that was the simulation in the research. And yeah, I will tell you about the analysis and conclusion in the end. So the concept of mobility as a service, we also need to define that. We define it as a platform enabling mobility services. And usually it looks like this. You have some kind of app in your mobile device, or you have some kind of you can have a smart card, or you have a SL card, or a Västtrafik card, or you have some kind of personal device or unit or card, and then you have like a communication network with different providers, and this is like mobility providers for us. It's like taxi cars, you have trains, you have different modes of transportation, and you have certain components of this as well, like databases, localization services, and we try to define it in a very abstract way because there's so many different types of ecosystems, because we have in our theory part, I will explain as well, but we have like one system in Sweden, we have one system in Finland, and in Sweden we also have one system in Västra Götaland, because it's regional based with the different länsstyrelser. I don't know the word for it in English. The different counties actually are the head owner of the different systems. So that created the challenges with interoperability between different mobility providers in Sweden. And then you can imagine like how Uber transformed taxi companies, and you have all sorts of different dimensions to this kind of word of mobility as a service. But our definition, it derives from Helsinki in Finland, that it was stated like this: a system in which a comprehensive range of mobility services are provided to customers by mobility operators. And then we started out to define that user experience is only the tip of the iceberg. So we tried to look deeper down in the system as well, and how different services are integrated, and also that multiple mobility providers are integrated. Also multimodal transports. Have you heard about that term? Where you have, as I said in the beginning, like you have taxis, you have cars, buses, and you can start like Yubico, start to integrate that. And also solving the urban density problems. It was kind of the issue is tried to grasp. And then we had some previous like frameworks to lean on, which are adapted from two different organizations. This was the Massifi. It's one research organization, and there's a researcher Lund. Also there's Samtrafik. In the next slide I will show you. But we use this kind of different distinctive components in the framework that can have different meanings in different domains. Like for me, institutional integration, it can mean that you have like legal issues, you have like a pest analysis, you can have different frameworks within this kind of components, like say ticket integration. It's very like, then you start to talk about the data integration and different systems and how you do bookings and different things. But if you try to think about these frameworks and see it in relation as how Yubico tried to position themselves and start to integrate and make like a pattern between these different components. Then we started to see that it was an extremely complex architecture, and it's like systems with a high variety of solutions and technologies. And this actually today has a very low level of interoperability, and that was quite the background of why we tended to see some kind of blockchain concept in this environment. Yeah, thank you. And also, yeah, these kind of frameworks it doesn't really show, but it's actually we have quite strong verticals today with mobility, like with mobility providers, which is like if you see SC as example, it's like a completely integrated environment where you have like they have the trains, they have the booking system, they have everything like in their own organization, which is where we start to see like the Web 2.0 concept, define what APIs are and how they tend to integrate themselves. And this picture is very good at explaining the different parts. So there's an issue today: who will be the integrator? Like, who will own this platform? Who will take care of the cash flow, the revenue streams? Who will make the profit in the end? Like, there's so many questions related to these issues. And when we started to look at the research question as well, was that we have to see that how can we do this? Who can play this part as being an integrator in such a neutral way as possible? And this is also the background to what blockchain really is, like how you can mediate peer-to-peer transactions without having a third party or a middleman involved in the transaction. So, yeah.
But if you're discussing having no need for a middleman, why do we talk about like integrator being in the center of this?
Because this is how reality works. You have all these parties, and they try to collude, maybe if you look at it that way, and they try to communicate and start to do business together, and then they start to create something called a consortium, and this is the result of that, samtrafiken. And when they start to do like a consortium, they can agree on the profits, and they can agree on different legal frameworks and how to do business with each other. And yeah, and they also try to transform the whole mobility domain as well with their own mobility program. They have started out with this thing called a white paper, which is a funny term as well as in blockchain, but that was actually the concept was to changing the concept of public transport, which is equal to passenger transport with shared resources. And we also use those kind of definitions in our thesis.
So I think also to your question that why the term integrator when blockchain potentially provides something that's way more peer-to-peer. And I think one of the reasons is basically because that's the word people were using before. So it's kind of like linking that and trying to make that more disintermediated.
I mean, even without the blockchain, what you can do instead of opting for some integrator, you can adopt some industrial standard, like what technology does with ISO standards. or electricity with IEC standards and say that there is no middleman, but everyone has to play by these rules. This part is legal, this part is technical.
Yeah,
So
I mean
then it's decentralized, and there is strong enforcement of every link in
I
decentralized.
mean that's a good like ideal to have, but in practice you're gonna have to have some central point where like people interact with, and like can you construct that central point, even if it's just like a logical central point? How can you do that?
Maybe you can continue. Just also describe blockchain technology.
Yeah, we're gonna get to that.
Yes.
And so that everybody understands.
Yeah. That will be the final. But like for the integration issue, as you just focus on one problem here that this organization tried to solve is with the ResPlus system. They wanted to have like one ticket that you could use on all these different services, and we tried to look about like how many trips do they account in this kind of platform, and how many of the stakeholders are actually the bulk of the travels. Like for the public transport system, they actually move a lot more people than the taxi companies, and how do they comply with the different costs, because operating a taxi company may be way more expensive than operating a public transport system that is actually also subsidized by the government and the state and the region and the counties. So they have different perspectives on how to operate. And also with the analysis, we used some kind of framework. This is adapted from two Finnish researchers. I don't know if you've seen this before. This is actually there's another part of this, but I won't go into that as much as detail. But it stems from the telecom industry, but it has been reshaped for explaining mobility services as in transport as well. And like today we have like a monopoly model with if we look at public transport companies, they have these natural monopolies, and you have some kind of GSM model. When you start to centralize, you become like a GSM model where you have like Samtrafiken, where they start to make these connections and start to make business. But what we see is that in the overall theme of mobility as a service, they tend to move up into an open ecosystem. But what we did actually, when we kind of figured out that blockchain is a good fit, is that when we start to decentralize these organizations, and how do you move from a GSM model into an internet model where you can sustain the high competition without making any organization or company unhappy, if you say it like that. So instead, if you try to remove all the legal barriers, and if you tend to liberalize the economy in some way, you end up here where you have a fragmented model, which is not good for the customers. So as I said, today platform sponsors' paradox is that they build alliances like consortiums. Then they tend to exploit first mover advantages, and third, they will manage the consumer expectations, because they still have quite natural monopolies, so they can actually design their whole experience or their services around the consumer's expectations. Like if you have taxi company, they can differentiate, and they have like high-end taxi cars or low-end taxi cars, and what will that do to the market, and so on.
So analyze barriers of entry, because I think it might be a little bit complicated picture, because and also not applicable to all services. Like with the internet model, it doesn't actually apply to Google. Google is the search provider, there is no regulation, but it doesn't adhere to fragmented model or internet model. It's more like GSM model.
Yeah.
Or because I see it as the barrier of entry is increasing towards the monopoly, and that's the natural. It's not like the one company monopolizes, but barrier of entry rises. For example, Google, I think it indexes like 50 billion documents. So basically, if you want to compete with Google, not only you need technology, but you need to actually go around the web and index 50 billion documents. So that kind of naturally drives it. So I don't think that internet model actually applies to all internet-based services.
Yeah.
So I think an interesting question there is like, how can we create this kind of natural monopolies, but in a way that there's not one company that gets the profit or that gets the benefit from that.
Yeah.
And that's one of the things that we looked at when we started to look at blockchain. So we're going to get to that in the next slide.
Yeah. Actually, to answer your point, there is to step out of the thesis presentation a little bit. Is take the Google as an example with their knowledge graph and how they index the information. They use that as a proprietary knowledge graph. It's like proprietary technology of Google, but they don't share that with others. You can't go on DuckDuckGo and search in index of Google. Like, they don't share that with others. What we try to do is solve that issue. How can you share information and have this interchange and interoperability between different parties? And now there's also with the internet, like the trend on the web is to use like linked data and semantic web technologies to increase these kind of connections and try to build new graphs of new information. And blockchain is a cornerstone of that, I would say. Which is now we're going back into the thesis as well. So you can start to explain the concept of blockchain.
So while we took all these concepts into consideration, we started to looking at blockchain technology. And before I go on, I just want to check how we're doing with time.
You have like 20 minutes.
Okay, then I'm gonna try to speed it up. So basically, to understand what blockchain technology is, we need to look at the history of the internet. So when the internet started, it was basically just a network where you could share information. So you could share ideas and you can talk about stuff. And that was like a very niche thing. People could send emails, they could have discussion forums, but it couldn't really do any commerce or stuff like that because everything that you published on the internet was automatically public. Then there was an innovation called HTTPS, and basically that was a cryptography tool that allowed anyone to encrypt information from the sender to the receiver. And that allowed us to send credit card numbers in a secure way over the internet. And as you all probably know, being able to buy stuff on the internet has radically changed how we do commerce and how we interact. But HTTPS and this kind of basic encryption that's just a very crude cryptography tool. And over the last 20 years, we have developed like a large amount of different types of tools for cryptography. But it wasn't until 2008 when Satoshi Nakamoto released his Bitcoin white paper that we actually got an approach to utilizing more of these very advanced cryptography tools on the public internet. So we have gone from like an internet of ideas to an internet of payments, and now we're moving into an internet where we have we can move all of the financial institutions that build up monetary infrastructure, and we can move all of them from centralized bank. We can move them onto the internet, and we get some kind of internet of agreements. So another way to look at this is like if you have computers at companies and as individuals, you have your own like database or view of the world. You have your own perspective with the data that you hold. So if I'm a person down here and I want to interact with two different companies, I need to send my information to that company, and then later I need to send it to the other company. So that's very much work for me, and it's inefficient. So one way we've traditionally tried to solve this is that we introduce a trusted intermediary, and basically you can think of like bank ID as this kind of solution where you have trust in a single authority for relaying information about you to different services. And this could also be like when companies interact, they have a trusted middle point. But there are some obvious problems there, like what if that organization is corrupt, or what if that organization crashes in some way? And to the right, we have like what a blockchain system provides. Basically, we can communicate and come to agreement about the current state of the world, of the network, and we can all agree that this is what has happened up until now. And then we can add on new information, and everyone can agree that this information is where we are now. And we do this without any trusted intermediaries. We can just do that with the protocol that we're all talking. So we're all talking the same language and use that to come to agreement of what has happened. So one of the interesting thing that we can use this blockchain technology for is something called a smart contract. So the first thing that blockchain was used for was money with Bitcoin, but smart contracts allows us to create some business logic and put that on the blockchain. And since the blockchain is a way for us to agree on what has happened, we can agree on what happens when this piece of business logic of programmable code executes. So basically, if let's take the example of I want to go from point A to point B, and I want to be sure that a company will come and pick me up, and the company will be sure that they get a payment. So I create a smart contract, I send that to the network, then I get 2 responses like, hey, I can drive you to that place, or I can take you there. And you choose the one that you like the most. And when you sign that I want that one, automatically you will know that someone will come and pick you up, and the one who picks you up knows that when they have delivered you to point B, they will automatically get the payment. Yeah, so this is a more technical image of like how the data structure of a blockchain works. So basically, in the network there is a lot of transactions that happen. So if you think about the money use case, you send money to someone, that's a transaction, and all of these transactions get clumped into one block. And as you see here in the block 11, and when the block is created, that block references to the previous block, and so on. So transactions block reference to the previous block, and then there's like a consensus algorithm that describes the rules for how we come to agreement of what has happened. So I hope that was like you have like a pretty decent understanding of what a blockchain could provide now.
In the bottom line is that it's a distributed system. There are some components in different blockchain technologies that differs, like the consensus algorithm, and there's different parts of it. If you're interested, we can answer any questions afterward as well related to this.
Alright, so summary. It's self-executing piece of business logic. This contract will be executed as written, and there is not really anyone who can just stop it. It's just following the rules of the system. And also, blockchain can be viewed as a database, so where you put the information, and that information cannot be changed in the future. So we have a history of things that has happened and that cannot be altered.
But who can view that information?
It's public information. So What we're talking about is a public blockchain where everyone can view this information. It's publicly available. There are some cases where companies come together and create consortia and like private blockchain. But we think that those are for like a more limited set of application. The public blockchain is what is interesting in our case.
Yeah.
So let's move on. So we did also a bunch of interviews. So we this is the qualitative part of our research. So we went around to different mobility companies in Gothenburg and asked like what would they see and benefit from in a centralized mobility provider, and like some questions around that. And we also introduced the topic of blockchain and got their perspective on like how that could be beneficial to them. So that was like the one of the parts of our research. So the requirements that we got really from the interviews was that there's a need for identification. I need to know the identity of the one who's going. So, but in a carpool, for example, you need to know that the person who is renting the car has a driver's license. Then we also need some kind of, we call it an agreement platform. And basically what it is that if I want to go from point A to point B, I can agree with a service provider, and the service provider should know that they will get the payment, and I should know that I will get from point A to point B. And that should be in some sense in a platform that is not just that service provider's in that service provider's hands. And then the third requirement for a combined mobility service is we need a way of route planning, and like how can we actually get there. So the applications that we came up with that can be used by a blockchain is basically identification and the agreements in the system. So with the identification, we can have you can create your profile that's linked to the blockchain. The data will not be public on the blockchain, but it's linked to the blockchain so that you get the permanent identifier that is anonymous, but then you can link that identifier to your data. What that provides you with is that you can use the same data when you interact with different services. You don't have to input your data when you're interacting with multiple different services.
So it's not really anonymous then?
It is anonymous, and you choose who you reveal your data to.
But then you basically can. This is mainly what most of the recent attacks on many technologies, and including recent attacks on CPUs with the meltdown and Spectre. Basically, you take indirect. You take those identifiers that are ostensibly anonymous, and then you observe a lot of activity of people. For example, if I come to the coffee shop and I pay with some identifier that is anonymous, but the coffee shop owner knows me, they can see that, okay, that person bought something at 10 a.m., but I know that face. So then you can de-anonymize.
So there's definitely a lot of technicalities here that can be improved, but I think the main benefit here is that you can have your identity, and then you can selectively disclose what information that different parties know. So I might choose to disclose some of my information to you and some other information to another person, because I trust this other person less than I trust you, right? And that's the thing that's useful here. So I don't want my driver's license to be publicly available. I want it to be available only to the companies or the services that I want to rent cars from.
But we'll still need to rely on trust here, right? Because you won't trust my information about my driver license. You will want to have that information to be cryptographically signed by some public authority. So
How
so differs from SAML authentication based, for example, KDH, when you or I don't know.
So
when you log in,
yeah,
you choose what data to.
the difference is that your identity in that kind of system, it's owned and controlled by some central authority.
It is, but
in this system, your identifier is owned and controlled by you, and then you get verification and data from other people that you can choose to reveal. So you are in ultimate control of your identity rather than, say, bank ID or some other type of system where the banks or some other entity is in control of your identity.
You have 5 minutes.
Okay, let's move on. So the next thing we did was to do a agent-based model, and basically what that is that you have a bunch of programmatic agents that interact with the system, and we tried 2 scenarios. One where there is a platform that is controlled by a consortia, and one that's more public on a public blockchain. And the result of that was basically that with no platform, we got the distribution of usage of the different mobility providers. With a consortia platform, we got a different distribution where the consortia won over the people or the platform, the providers that was not in it, and with a public platform, it was more equally distributed. And we also tried to see, like, we gave users the option to choose a more environmentally friendly option. And basically what happens is that when there is a consortia that have only a few of the mobility providers, they will get a way worse. The people will be worse off to choose the environmentally friendly options. And with an open platform, they were more able to choose those kind of environmentally friendly options. So I think you can go.
Yeah. To sum up then, our conclusion is that blockchain has the potential to solve fundamental problems in mobility as a service. Neutrality requires a public blockchain. We didn't specify now for you what the difference is between a public and a private blockchain. We can answer that later. One of the most important parts here is that the diminished transaction cost. What this means, it renders a whole different following up presentation on why it is like that. It relates a little bit on how you link up in this ecosystem and what kind of language do these systems speak. Yeah. Then we have some extra slides I will show you because we have some minutes left. I'm involved in another project now as well. It's started in Åbo University in Finland, where they try to create a new model. This is not fully organized. We are defined as a hub right now in Sweden, but we will start to work together with the Svensk Standard, the Swedish Institute of Standards, I guess, to define what this is. And we tend to live in this world right now, the API ecosystem with the API economy and what that means. And what different actors as Google and these huge multinational companies tend to do is to create a world for us that is aggregated, and we buy it completely today. We live in this world, if we like it or not. So what this actually want to create is a model for how you can self-manage your data and how you can be in charge of your information and
basically
so
user-centric data.
Yeah, user-centric data. And so, yeah, user-centric approach to different domains, as you can see. And then funny thing when we ended our thesis is that E&Y have started to launch a platform of their own after our thesis. I don't know if they read it and published something. I don't know, but that's the development. And then I added a third picture from IBM. Like what is you can't see it. It's a contour of the car here, but kind of the hottest topics and the buzzwords in mobility currently, and blockchain has emerged here. So yes, thank you for listening.
Thank you. time for some questions. So if you need to leave, you're free to do that. But
I have a question on the conclusions slide, if you can go back to that.
Of course.
You mentioned that the blockchain has the potential to solve fundamental problems in mobility systems. Could you please name those problems?
So I think one of the problems is that when if you want to create this combined mobility service, basically what we looked at was someone who has tried to do that before. It was called Yubico, and they were trying to be a for-profit company that created this app and platform that integrated these different services. And what we think that, or from the interviews, what we learned that they basically fail on is that for the integrators to want to do that, they don't want some random company to be making profits on their rides or on their customers, and also getting the data from all of their rides. So what we understood was we need some kind of more open platform where this sharing of data and of customers can be facilitated in. And that's where we think blockchain is a really good fit.
I think it should be directly mentioned in the conclusion so that it's more understandable.
Yeah, thank you for the feedback.
Thank you.
Yeah. I think it all goes down to trust, like how you trust this mediator or third party. And Yubico was too small, and Västtrafik, for example, in Västra Götaland, the county of West Sweden, they only allowed Yubico to work with 70 of their customers or 70 households. So that was quite a limited project. And how can you scale up? And there was some issues that we identified as fundamental problems in that model. Yeah.
And that's really interesting now here in Stockholm, because Yubico will launch in Stockholm this spring, and they would like to integrate some fleets offering, but they can't because, of course, some fleet would like to have the customer themselves, the contact with the customer themselves. So they're building on each other. So I don't know if will really blockchain take away that problem.
I mean, I would say that either we have this competition where we try to step on each other's toes and get to the top, or we start to collaborate. And that's really the two options that we have. And the thing is that when we collaborate in a more open environment, things are going to get so much more efficient.
Yeah, so examples of this, when we look at the agreement and the identification of say a user on this platform, is that they can use certain parts of blockchain technology to prove their identity, and they can do it in a way that is have a very high level of integrity for both the service provider and also the customer or the person buying services. So there are some parts of this that we state as potentials because it has not been tested yet, and
I think we had
How was the climate when you were out talking with companies and stuff? Were they against this kind of blockchain technology application, and or because I think that maybe these companies can profit more from having this not inefficient systems where they each and own can maybe profit more than rather when they collaborate. Do you see my question? Were they happy to talk about this blockchain technology, or were they against it?
So basically, most of the people we talked to, they didn't know about what it was, and when we told them about it, they saw that there's some possibility here, but they couldn't. It was hard for them to kind of extrapolate exactly how that would impact their businesses.
Yeah. There's also in this thesis there's some ethical parts as well. For us, we are maybe biased towards using blockchain technology, and if we kind of put that our assumptions on the interview, the people we interview. I don't know. We haven't followed up on that kind of issues, but it's interesting when you see the trend of how the different industries tackle the challenge with using blockchain in different areas. We think that we have not influenced our subjects too much. There's also like integrated, or with blockchain, when you integrate business logic in this technology, for a company, I can say it like this: we are very used to using accounting as a tool or a method for describing our economy. What if we integrate accounting into the business logic of making a contract? That is kind of the thing blockchain can do. Like you integrate certain methods or processes or
I think that's
tools.
a very good point.
Yeah, so that is a completely new world that open up when you don't need to have separate accounting departments. And if we ask Vestra, like how much money do you spend on accounting per year? And by using this instead, you can do like that. And there's some issues also we identified with, for example, if you have a multimodal transport, when you go from A, B to C to D, you use these different modes of transportation. If you have a taxi company and you have a public transport system, and how do you differentiate the cost of your travel or the cost of the user in that system? And you can have a smart contract in regulating and differentiating that cost autonomously. You don't have to have like a fixed price list or anything. You can have a GIS system with this spatial algorithm that make up for it, and you can have a trust system in place that people actually trust it, and you have organization and companies trusting it, and you don't need this middleman as maybe Yubico try to mediate a contract and a service level agreement and try to make this manually, and hopefully they will get some fleet to offer their cars and they will share their customers' data, and then you have GDPR and all those issues. So there's a complex work. Yeah.
So maybe we start with that vision. End with that vision about that. So maybe you will still be here. So if you have questions afterwards, you can.
Yeah, please.
Yeah. But thanks again. Thanks a lot for coming.
Yeah, thanks for having me.